Hi everyone, this is Mrs. J, and today we're going to be defining and evaluating trig functions in the unit circle. So I have a quick warm-up for you guys. If you could pause the video and give it a try, we can check your answers in just a few moments. All right, so you can see here I was able to fill out our chart using these special right triangles, which you should have hopefully memorized from geometry. So remember, SOHCAHTOA helps us remember the ratios for our three trigonometric functions, sine, cosine, and tangent. So sine is opposite over hypotenuse. So for 30 degrees, if you look opposite over hypotenuse, it's 1/2. For 45 degrees, it's 1 over root 2, which we're going to write as root 2 over 2. And then here's 60 degrees, opposite over hypotenuse is root 3 over 2. So you can do the same for cosine. So cosine of 30 degrees, remember, is adjacent over hypotenuse, so root 3 over 2. For 45 degrees, it's 1 over root 2, which gives us root 2 over 2, which is how we'll commonly see it. And then for 60 degrees, here's 60, adjacent over hypotenuse gives us 1/2. And then for tangent, remember tangent can be found by doing opposite over adjacent side. So for 30 degrees, opposite is 1, root 3 is adjacent, so 1 over root 3, which we'll write as root 3 over 3. For tangent, it's 1 over 1, which is 1. And then for 60 degrees, it's root 3 over 1, which is just root 3. So if you know your special right triangles, you can find the sine, cosine, or tangent of any type of 30, 45, or 60 degree angle, which we'll be using a lot today. So make sure you have this chart handy, and also make sure you could recreate this chart quickly for maybe a quiz or a test. All right, so today we're going to start by learning how to find what's called the reference angle. And our reference angle is going to be probably one of the most useful things we work with in trigonometry. It will help us evaluate any trig ratio from the unit circle that we come across. So a reference angle is the angular distance to the closest x-axis. It's always the distance to the closest x-axis, not the y-axis, it's always the x-axis. The reference angle we always consider to be positive, and you can denote it with theta prime. So that little tick mark, theta prime, that's how you show that it's the reference angle. So now we're going to practice finding the reference angle. So how I recommend starting these types of problems is by sketching out a quick picture of where our angle falls. So if I have theta equals 150 degrees, I know that that is somewhere in quadrant 2 because it's between 90 and 180. So here's theta, but again, we want the reference angle. So the reference angle, so I'll label this as 150, is again the distance to the closest x-axis. So I can see here that our reference angle is actually going to be this distance. So I'll label it theta prime. So remember, this horizontal axis is 180. So we're essentially just finding the distance between these two angles. So we do 180 minus 150, and we get 30 degrees, which means that our reference angle is 30 degrees. So you guys are going to see that since our reference angle is 30 degrees, 150 degrees acts almost exactly like 30 degrees acts. We would use the reference angle to help us evaluate. Okay, let's try this next one. Here we have theta equals 7 pi over 6. So this is in radians. So remember, 7 pi over 6 is like saying 6 pi over 6, which is pi, so it's right here, plus that extra slice, giving us 7 pi over 6. So it's in quadrant 3. So the angle is this, 7 pi over 6. But we just want the reference angle, which again is the distance to the closest x-axis. So it's this distance right here. So remember that horizontal axis is just pi. So we want the distance between 7 pi over 6 and pi. So we can use subtraction. We're always going to do the larger angle minus the smaller angle because our reference angle is always positive. So we do 7 pi over 6 minus pi. And it might be more useful to make a common denominator. So we get pi over 6 as our reference angle. That's the distance to the closest x-axis. It's actually really easy to find the reference angle for when we're in radians. So it's essentially always going to be whatever your denominator is. So since it's 7 pi over 6, our reference angle is just pi over 6. And if you kind of jump ahead to part D, this reference angle is just going to be pi over 3. But we'll confirm that by graphing and checking anyways. But it is pretty quick and easy to find reference angles when it is in radians, which is why I prefer radians. Okay, now let's do part C. We have negative 225 degrees. So we need to start by figuring out what quadrant that's in. Remember, negative angles travel in a clockwise direction, so they go actually this way. So negative 225 would put us in quadrant 2 because it's between negative 180 and negative 270. So this is our angle. But again, we want our reference angle, which is the distance to the closest x-axis. So I take my angle and I connect it to the closest x-axis. This distance is our reference angle. So again, this is negative 225 degrees. This would be negative 180. So we just find the distance between these two angles. So we can do negative 180 minus negative 225, and we actually get 45 degrees. So theta prime equals 45 degrees. That's our reference angle. All right, and for this last one, let's start by plotting it. So again, we're moving in that negative direction. So we're counting by pi over 3. Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So in the negative direction places us all the way in quadrant 1. So it's going in this direction. There's theta, negative 5 pi over 3. And we want the distance from the angle to our closest x-axis, which in this case is right there, which would be negative 2 pi if we continue going in that direction. So we're going to subtract. We can say negative 5 pi over 3 minus negative 2 pi, and we can create a common denominator if it helps. So minus negative 6 pi over 3. And you can see that that gives us pi over 3. So theta prime equals pi over 3. So remember our little trick, if our angle is in radians, we really just look at pi in the denominator. So negative 5 pi over 3, the reference angle is just pi over 3. So this is how we find the reference angle. And again, we're going to be using the reference angle heavily this lesson and the rest of our trig unit. So please make sure you really understand how to find that reference angle, whether it's in degrees, radians, and whether it's positive or negative. Okay, so go ahead and pause the video and see if you can give these 4 a try, and we will check your answers in just a few moments. All right, so go ahead and check your work. For part A, our angle is in quadrant 1, 45 degrees, and actually the distance to the closest x-axis is also 45 degrees. So in this case, the angle is also the reference angle. For part B, 4 pi over 3 falls over here in quadrant 3, and the distance from here to here is pi over 3, so that's our reference angle. Negative 300 degrees falls in quadrant 1, and the distance from negative 300 to negative 360 is 60 degrees. Remember, the reference angle should always be positive. And then last, negative pi over 4 falls here in quadrant 4, but you can see the distance from that line to the closest x-axis is just pi over 4, so it's just positive pi over 4. Okay, so here's how we can evaluate our unit circle angles. So if we have a trig ratio involving some form of 30, 45, or 60 degrees, we can follow these steps. So step 1 will be to draw the terminal side of your angle. So sketch a graph so we know which quadrant we're working in. And then we're going to find the reference angle. And then we can evaluate the expression using the reference angle instead of the original angle. And then we can also use that little chart that we created in the warm-up. And then we simply need to determine if our answer is positive or negative based on which quadrant it's in. So how do we know if it's positive or negative? We have this little chart to help us. So here's your 4 quadrants, and this chart tells you which functions are positive in each quadrant. So in quadrant 1, all of your functions are positive. Sine, cosine, and tangent are all positive. In quadrant 2, only sine is positive, which means cosine and tangent are negative. In quadrant 3, tangent is the only positive one, meaning cosine and sine are negative. And in quadrant 4, cosine is positive, meaning sine and tangent are negative. So one thing you can do to help remember this, a really common mnemonic device for this, is all students take calculus. So ASTC, all students take calculus. And again, this should help you remember which function is positive in each quadrant. So that will help us determine the sign of our answer. So we're going to follow these 4 steps to help us evaluate our trig ratios. All right, so we're going to try these 5 problems together. So we're going to evaluate the following expressions. So first, we have sine of 5 pi over 6. Remember, step 1 is to sketch a picture. So 5 pi over 6, it's almost 6 pi over 6, but it's short 1 slice, so it's back here in quadrant 2. So here's our angle. So we've sketched the terminal side of our angle. Step 2 is to find our reference angle. So remember, it's that distance to the closest x-axis. So it's the distance from 5 pi over 6 to 6 pi over 6. So we can see here that our reference angle should be pi over 6. And then again, we can, instead of evaluating sine of 5 pi over 6, we can actually evaluate using the reference angle. So we can actually say the sine of pi over 6, which if you look at that chart that we created on the warm-up, we know that the sine of 30 degrees, which is pi over 6, is 1/2. And then we just need to determine, is our answer positive or negative? So we know that in quadrant 2, sine is positive. So in quadrant 2, sine is positive. So our answer is simply positive 1/2. Okay, let's look at the next one. So here we have 7 pi over 4. So let's first sketch it. So 7 pi over 4 is almost a full rotation, which would be 8 pi over 4, but we're missing 1 slice. So this would fall in quadrant 4. And here's our angle. So this is 7 pi over 4. But we want to really work with our reference angle, which is this distance. So the distance from here to here would just simply be pi over 4. So theta prime is pi over 4. So instead of doing the cosine of 7 pi over 4, we can just take the cosine of our reference angle, pi over 4, which if you look at the chart we created again, it should be root 2 over 2. And then again, we just need to decide, is our answer positive or negative? So remember, all students take calculus. So in quadrant 4, cosine is actually positive. So our answer is positive root 2 over 2. Okay, let's look at the next one. Here we have 240 degrees. So we're going to sketch it first. So we know that this is between 180 and 270, so it's somewhere in quadrant 3, like this. So here's theta. But we want to work with our reference angle, so theta prime. So this distance from 180, between 180 and 240 is 60 degrees. So theta prime equals 60 degrees. So instead of finding the cosine of 240, we can just find the cosine of 60 degrees, which we have from our chart. It's equal to 1/2. And then we need to decide, should our answer be positive or negative? So we know all students take calculus. So in quadrant 3, only tangent is positive. So that means that in quadrant 3, cosine is actually negative. So we simply take the answer we got and we just make it negative. So it's actually equal to negative 1/2. All right, let's do one more, or the next two together, sorry. So let's start with tangent of 660. So first thing to note, 660 is a large angle. It's a little difficult to work with. So I'm going to recommend finding a smaller coterminal angle. So remember, we can do that by simply subtracting 360 degrees. And that coterminal angle would be 300. So the tangent of 300 degrees is exactly the same as the tangent of 660 degrees. So we'll just be working with this one from here on out. Okay, so let's sketch where this falls. So it's between 270 and 360, so it is in quadrant 4. So here's our angle. But we would like our reference angle, which is right here. So we can see the distance from 300 to 360 would just be 60 degrees. So that's our reference angle. So instead of doing the tangent of 660 or even the tangent of 300 degrees, we can just take the tangent of 60 degrees, which we do have from the table that you created in the warm-up. So the tangent of 60 degrees is √3. And then we just need to know, is our answer positive or negative? So if we do all students take calculus, only cosine is positive in quadrant 4, which means in quadrant 4, tangent is negative. So we take our answer here and we just make it negative. So it becomes negative √3. And last, we have the sine of negative 5 pi over 3. So let's sketch that really quick. So again, we're moving in that negative direction. So it's almost a full rotation in the negative direction, but we're short one slice. So it falls in quadrant 1. This is negative 5 pi over 3. Let's find the reference angle because that's what we work with. So the distance from here to here is just pi over 3. Remember our little trick, it's really just pi and then the denominator. So theta prime is pi over 3. So we can just take the sine of pi over 3, and the absolute value will be the same as the sine of negative 5 pi over 3. So remember, pi over 3 is 60 degrees. So from your chart in your warm-up, the sine of 60 degrees is √3 over 2. And then we just need to decide, is our answer positive or negative? So in quadrant 1, all functions are positive. So in quadrant 1, that means that sine is positive. So our answer is just positive √3 over 2. And there you have it. So again, we're finding the reference angle, well, we're graphing where it falls. We're finding the reference angle and evaluating using our reference angle and the chart you created in the warm-up. And then you just need to decide, should your answer be positive or negative based on that ASTC chart. Okay, so at this point, I'm going to ask you to pause the video and give this one a try, or these three a try, and then we'll check your answers in just a few moments. All right, so go ahead and check your work. So for a tangent of 135, it falls in quadrant 2, so we know that our answer is going to be negative. Our reference angle is 45 degrees, so we're just taking the tangent of 45 degrees, which is 1, and then we make it negative. For part B, I found a smaller coterminal angle by subtracting 360 degrees. So the sine of 210 degrees will be exactly the same as the sine of 570. Coterminal angles have the same trig ratios. This falls in quadrant 3. So we know that our answer is going to be negative because sine is negative in quadrant 3. Our reference angle is this distance. Our reference angle is 30 degrees. So we just take the sine of 30 degrees, which is 1/2, and then make it negative. And last, the cosine of negative pi over 6. This falls in quadrant 4. In quadrant 4, cosine is positive, so we know our answer will be positive. And our reference angle is just positive pi over 6, and the cosine of pi over 6 is the cosine of 30 degrees, which is √3 over 2. So you might have noticed that we left out some angles, some really commonly used angles, which would be the angles that are on our axes, like 0 degrees or 90 degrees. So you'll see that those values weren't in our chart because we couldn't find them using our special right triangles. So how do we evaluate those? We can actually evaluate our axes like our 0, 90, 180, 270, and 360 using the coordinates from the unit circle. So by definition, a unit circle is just a circle that has a radius of 1. So that's really important to know. So a unit circle is a circle with a radius of 1. So for any unit circle, the cosine of that angle can be found by just being by looking at the x value of your coordinate. The sine of that angle can be found by looking at the y value of your coordinate, and the tangent can be found by looking at y over x. So let's see, why does this work? Let's just take this first angle we see, which we know is 30 degrees. But let's just look at this angle. So let's say I draw this angle, and I'm going to actually turn it into a right triangle. So if I turn this into a right triangle like this, so again, this is where the tip of our angle is. We know that this is just x units. Anything horizontal is x, and anything vertical is y. So this coordinate would be x, y, whatever those distances are. And since this is a unit circle, the radius is 1. So the length from here to here, that's a radius, would be 1. So now if we're trying to evaluate this angle, let's do SOHCAHTOA and set up our ratios. So let's start with cosine. According to SOHCAHTOA, we know that cosine of any angle can be found by doing the adjacent over the hypotenuse. So in this case, it'd be x over 1. So that means that the cosine of any angle can be found with just the x value of our coordinate. And again, it must be from a unit circle. This only works for a unit circle. Well, now let's do sine. So we know according to SOHCAHTOA, sine of our angle will be opposite over hypotenuse, which in this case is y over 1. So the sine of our angle can be found by just using the y value of our coordinate. And then the tangent can be found by doing opposite over adjacent. That's our tangent ratio. So it's y over x, which is what we have here. So if we know the coordinate, we just take the y value and divide it by the x value. So we can actually take the coordinates of the angles that are on our axes, and we can use the x and y values to help us evaluate. So here's 0 degrees, so right here. So this is 0 degrees. So let's look at what this coordinate would be. Since this is a unit circle, the length from here to here is 1 because it's a radius. So we're going 1 unit to the right and 0 units up. So this coordinate is 1, 0. And then if we look at 90 degrees right here, right, again, this distance of this line I'm drawing is 1. So we're not moving left or right, but we're going exactly 1 unit up. So this coordinate would be 0, 1. If we look at 180, we're just moving to the left 1 unit, so that coordinate would be -1, 0. If you want 270, you're just moving down 1 unit, so that would be 0, -1. And then again back to 360, it's just 1, 0. So we can use the x and y values of our coordinates to help us evaluate. So let's start by finding the sine of all of these values. So remember, the sine of our angle can be found by looking at the y value. So the y value of our coordinate. So the sine of 0 degrees is 0. Again, we're looking at the y value. The sine of 90 degrees is 1. The sine of 180 degrees is 0. The sine of 270 degrees is -1. And the sine of 360 degrees, again, is 0. Now let's do cosine. So remember, the cosine can be found by looking at the x value of all of our coordinates. So we're going to look at all of our x values. For 0, the x value is 1. So the cosine of 0 is 1. The cosine of 90 is 0. The cosine of 180 is -1. The cosine of 270 is 0. And the cosine of 360 is 1. And then for tangent, we can find tangent by doing the y value over the x value. So one thing to remember, if your denominator is 0, it's actually undefined. So we are going to have some values that are undefined, which is actually correct. There are some undefined values for tangent. And you'll see why when we learn how to graph tangent. Okay, so let's finish filling out our chart. Again, we're going to be doing our y value over our x value. So for 0, we do 0 over 1, which is 0. So the tangent of 0 is 0. For 90, it's 1 over 0, which is undefined. So the tangent of 90 degrees is actually undefined. For 180, it's 0 over negative 1, which is 0. And for 270, again, we have negative 1 over 0, which is undefined. And then back to 360, we have 0 over 1, which is 0. So now you can find the sine, cosine, tangent of any of our angles that are on the axes, our quadrant angles. And then we also, again, have that chart that we completed from the warm-up that has the sine, cosine, and tangent of 30 degrees, 45 degrees, and 60 degrees. So now you should be able to evaluate any of our common unit circle trig ratios using the steps we learned today and the tables that we were able to create. All right, so that is all for today's lesson. Thank you so much for watching.